Hello students, I would like to say welcome to all of you for this Misostudy video class. Now, as it is clear to all of you that what exactly we are going to discuss in today's video class, that is JEE main pattern questions. Exercise means questions, and the topic that I picked is magnetism and matter. In this particular chapter, we are supposed to understand, we are supposed to learn Earth's magnetism, magnetic materials and other related topics. In general, students don't put a lot of focus on this particular chapter. Fine, they love to study EMI, electromagnetic induction, then AC, then you can say moving charges and magnetism, but this is also a very important chapter. And moreover, the most beautiful part of this chapter is simple questions without a lot of calculations. Fine. So let's start this chapter with very interesting questions. So this question in front of you, the angle of dip. Now I hope the question is clear to all of you. It is from the Earth's magnetism concept. The angle of dip at a place is 46.6 degrees and the value of sine 46.6 is given, and the intensity of the vertical component of Earth's magnetic field is V, and the value of V is also given. The total intensity of the Earth's magnetic field at this place is how much? Simply formula based question. Fine. So without wasting any time, what I will do, I will write down the formula. And if I am writing the formula, it not means the purpose has been solved. No, it means you have to revise the basic formulae associated with this chapter. So I is equal to V upon sine theta. Fine. The value of V is given and the value of sine theta is given, that is sine 40.6. So what I will do, I will suggest put the values, that is 6 into 10 to the power minus 5 upon 0.65. Fine. Now once you solve it, you will get the correct answer as 9.2 into 10 to the power minus 5 Tesla as your correct answer. Fine. Calculation is simple. I explained you the concept and the formula. It is the important aspect of this particular question. Fine. So I started my discussion with a question which has nothing to new but simply a basic result and then some calculation. So 2 points I hope now clear to you. Basic formulae you should practice a lot. Fine, they must be at your tips. And second aspect is make yourself more strong, more perfect in calculations, fast but accurate. So the message is twofold with the help of this question. Fine, and I hope it's clear to all of you. Then students, it comes question number 2. The magnetizing field of 2 into 10 to the power 3 ampere per meter produces a magnetic flux density of 8 pi Tesla. Okay, in an iron rod. The relative permeability of the rod will be how much? So target is to find out relative permeability. This is our target. How we can solve it? This question again based upon a specific type of approach and formula. Okay, what is that approach or this formula that we will try to find out? So now what is the formula for this relative permeability? Let's write down. Mu r is equal to mu upon mu naught. Fine. The basic result is with you. over here if you multiply this portion and this portion, means this denominator and numerator by capital H, that is magnetic field intensity. So H, fine. Next step, what you will get, this mu naught H is fine, but mu H is B. Okay, so what I can write down, mu R is equal to B upon mu naught H. Fine. Now the value of this B is 8 pi given. The value of mu naught H is given as 2 into 10 to the power 3, that is 4 pi. Mu naught is 4 pi into 10 to the power minus 7, and this H is equal to 2 into this value 2 into 10 to the power 3. So what I will do, I will not put the values, but I will suggest to all of you by putting the values and solving. By putting the values and solving, you will get 10 to the power 4 as your answer. So B is the correct answer of this question. Here only point is that you should remember this result. After that, multiplying on this numerator denominator by H and then putting the value is simple. Fine. So here in this question, once again, what is important parameter? The basic formulae must be at your tips. And this chapter basically you can say in mains and in your NEET type of exam, this chapter is very important. Fine. Here comes your question number 3. And in this question, a bar magnet of magnetic moment 2.0 lies aligned with the direction of uniform magnetic field of 0.25 Tesla. What is the amount of work required to turn the magnet so as to align its magnetic moment normal to the field direction? Bar magnet. Okay. So bar magnet is something like this. Fine. Now a bar magnet of magnetic moment M is equal to NIA type of formula. Fine. Lies aligned with the direction of uniform magnetic field, outside field. Okay. Ultimately, you have to find the amount of work. So if you can calculate the difference in energy, then amount of work you can easily find out. Okay. So what is the formula for energy? U is equal to minus mb cos of theta. Fine. Now this is your general formula. U is equal to minus mb cos of theta. You have to apply the same formula in two conditions. What are those two conditions? When theta is equal to 0. So cos 0 is 1. So what I can say? I can say U0 is equal to minus mb. I hope no problem. Then next is when theta is equal to 90, and in this condition U90 is equal to 0. Fine. So what is the work done? Work done W is equal to, I think I should erase out this portion and try to mention over here, that is W is equal to U90 minus U0. Fine. So U90 minus U0 means what? You have to put the values, that is 0 minus MV. Okay. So W is equal to U90 minus U0, that is 0 minus MV, that is M into B. Fine. Magnetic field 0.25 and magnetic moment 2.0. So 2.0 into 0.25. Now very easily you can find out the solution of this particular question, that is 0.5 joule. Fine. So this way you can say these questions are not difficult, all these three, but the only message I want to convey that you have to be very comfortable with the basic formulae of this chapter, not only but with the basic formulae of all these chapters, whether it is class 11 chapters, whether it is class 12 chapters. Fine. Then comes question number 4. A diamagnetic material in a magnetic field moves in which direction? Now here you know that the correct answer is C, from stronger to weaker, but I think I should explain in totality this particular concept. Basically you have diamagnetic, paramagnetic and ferromagnetic. In general, three types of materials. Diamagnetic materials gets demagnetized opposite to the field direction. Paramagnetic, very small amount magnetization in the direction of the field, and ferromagnetic, strong magnetization in the direction of this magnetic field. So for this diamagnetic, stronger to weaker. Fine. Paramagnetic, weaker to stronger, and ferromagnetic, again weaker to stronger. So for this particular diamagnetic material, from stronger to weaker, opposite to the applied field. Diamagnetic, opposite to the applied field. They will expel out external magnetic field applied on them. Paramagnetic, in the direction of the magnetic field, and ferromagnetic, very strongly in the direction of the magnetic field. So here this point, this question I not placed just for the sake of increasing the number. My idea was that by putting this question, I will give you a message that you have to at least read once or twice the properties of di, para, ferromagnetic, some important properties. Fine. Then it comes question number 5. A magnetic needle lying parallel to a magnetic field requires W units of work to turn it through 60 degrees. The torque needed to maintain the needle in this position will be how much? Fine. I am sure many of you will not able to understand what exactly the question is, because it's really true. You don't like it, it's not my problem, but yes, it's true. In this particular chapter, normally students don't take a look of these basic concepts. Fine. That's why I am putting these type of questions. So let's try to find out the solution of this particular question. Fine. Students, we know tau is equal to mb sin theta. This basic formula. Fine. Tau is equal to mb sine theta, let's say equation number 1. Next I can say and w is equal to 1 mb 1 minus cos theta, that is mb 1 minus cos theta. Fine. So you have these two relations, equation number 1 and equation number 2. So from 1 and 2 we can do something, and what is that something that I am trying to do? Fine. So tau is equal to wb sine theta, tau is equal to wb sine theta upon b 1 minus cos theta. Fine. W is equal to mb 1 minus cos theta. So tau is equal to mb sine theta, that is w in terms of, yes, deliberately I am mentioning that, and b into 1 minus cos theta. So what I can write down from here, that w sine theta upon 1 minus cos theta. I think I should resolve it, otherwise this simple step few of you will not able to understand. I think the approach should be like this. Let me make it more simple. The same thing but with a different approach. And okay, and w is equal to mb 1 minus cos theta. Now everyone can understand it. Then from 1 and 2, from 1 and 2, tau by w is equal to sine theta upon 1 minus cos theta. Earlier what I was doing, that was I was deliberately not writing two terms, but then I thought few of you may ask where are those terms, from where I am writing those terms. So now there is no scope of any confusion. Fine, I increased these two steps, but I hope now everything is clear. So from here I can say tau is equal to w sine theta upon 1 minus cos of theta. That's clear now. Okay. Now from here, given theta is equal to 60 degree. So put the value of 60 degree. Sin 60 is root 3 by 2, cos 60 is 1 by 2. Ultimately when you solve it, I think I should use this place, by putting theta is equal to 60 degree, tau is equal to root 3 w. Fine. No scope I left for any type of confusion. Each and every step even I explained, which I should not. Because if I am solving, if I am providing even a minute step, each and every minute step, I am not helping you, but I am creating problem for you. Why? Because if everything is present in your video, you will definitely not revise your basics. But if something I am missing, deliberately I am not writing, only then I am forcing you go back to your basics. But in few questions, I think I should do this thing, that I will provide each and every step. And my simple suggestion is, you never ever ask for every step to be solved by the teacher. Otherwise, what you will learn? So now let's move for question number next, that is 6. Again, this question I was initially planning to put this question at question number 5, But then I thought it's going to be very simple for thinking, because here my simple point by means of question number 4 and 6 is the basic properties of magnetic materials should be clear to you. Di, para, ferro, domain formation, you can say how the domains are arranged, how you can break the domains, and so forth and so on. Domain formation is the necessary function of, that's it. You know that. If you don't know that, please revise. The only thing that I can suggest. But here I would like to mention a very important point for all of you. That is, it's a suggestion. Di, para and ferro. Basic properties. Important. So give them a revision. It will take hardly 20 minutes. Hardly it will take 20 minutes, not more than that. Now let's come on for question number 7. A magnet is cut in two equal parts by cutting it perpendicular to its length. Okay. The time period of original magnet is T0 in a uniform magnetic field B. T is equal to 2 pi under root m upon h, b upon h type of formula. Then the time period of each part in the same magnetic field is how much? So the situation is like this. Okay. Now cut it. So this is one magnet and this is another magnet. What I will do directly, I will start applying the formula, because you have to just put the values in terms of formula, and by cutting only magnetic moment m is going to change. Fine. So here for each part, I1 is equal to I by 8. What is I1? New moment of inertia. What is I? Initial moment of inertia. Fine. So, and M1 is equal to M by 2. What I mentioned? That only this magnetic moment will change. So, M1 is equal to M by 2. Therefore, T is equal to 2 pi I upon MB. Is it like that B is changing? No. Is it like that I is changing? Yeah. M, of course. So now you have to use this relation twice. Fine. I1 every time is going to be like this, I by 8, and M1 is by 2. Fine. So by using this relation, fine, T is equal to 2 pi I by MB. Okay, no problem. So what about T1? I will write at this place only. This is initial value, and T1 is equal to 2 pi I1 upon M1 into B. Fine. Now what you are supposed to do? You are supposed to do T1 by T. The only thing you have to do is T1 by T. Now T1 by T, after putting the values and solving, I am saying it is 1 by 2. Fine. Therefore, finally T1 is equal to T by 2 is equal to T naught by 2. So now B is the correct option, okay. And solution is very simple. Only the thing which you should remember always, that is T is equal to 2 pi under root I upon M B. Just this formula you need to remember. And by these type of questions only, by practicing these type of questions, definitely you will learn so many things, you will revise so many things. So never ever feel bad about these questions. Here is your next question. The real angle of dip if a magnet is suspended at an angle of 30 degree to the magnetic meridian and the dip needle makes an angle of 45 degree with the horizontal is how much? Fine. So in this particular problem, this question is based upon dip angle. What I will do, I will simply write down the formula for this dip angle problem. Dip angle theta, let's say, fine. Then BH, what is this? Earth's magnetic field horizontal component. Earth's magnetic field horizontal component, and VB, Earth's magnetic field vertical component, VB and BH. Fine. Now, what is the relation between BH, BB and dip angle? So, tan theta is equal to VB upon BH. Okay. Now, tan theta is equal to BV upon BH cos of 30 degrees. Fine. So, from here you can say theta is equal to tan inverse root 3 by 2, or more properly theta is equal to tan inverse root 3 by 2. Fine. So, not a difficult question. Once again, the need is be comfortable with the basic formulae. Then, one or two questions which I tried to pick from basic properties of magnetic materials, that is this one. At a temperature of 30 degree centigrade, the susceptibility of a ferromagnetic material is found to be chi. This is Latin term chi, not x. Its susceptibility at 330 degree centigrade is how much? Now, it is something which is associated with the Curie temperature, Curie-Weiss law. Fine. So, first thing you have to do, revise those concepts. Then it comes the solution of this particular problem, that is chi m is equal to mu naught C by T, where T is what? C is Curie constant and T is temperature. Fine. So, what I can say that chi m is directly proportional to 1 by T. It means as the temperature will keep on enhancing, this value will keep on decreasing. Okay. So, I can say chi m m1 upon chi m2 is equal to T2 by T1 is equal to 606 upon 303, that is 2. Fine. So, it means new chi m2, that is chi m2 is equal to 0.5, because it is going to be 1 by 2. So, it will give you 0.5 or 1 by 2 value. Important is, because you know, if you start heating a ferromagnetic material, it will become para, and if you keep on heating para, finally it will become dimagnetic. So now here comes your question number 10. The magnetic susceptibility, up to some extent I try to repeat the concept. The magnetic susceptibility of material of a rod is 499. Permeability of vacuum means mu naught. 4 pi into 10 to the power minus 7 Henry per meter. Absolute permeability of the material of the rod in Henry per meter is how much? My suggestion is stop the video now. Why? Because you should try yourself and after some time run the video, match your answer. This is the best approach of learning. But let me provide you the solution. Chi is equal to mu r minus 1. Basic formula. Fine. Chi r is equal to mu r minus 1 and mu r itself is given as mu upon mu naught minus 1. You can write it like this. Arranging simple terms. Fine. Then just put the value. Chi m is given as 499. Mu naught is given as 4 pi into 10 to the power minus 7. You have to find out this mu. Very easily you can find mu is equal to 500 into 4 pi into 10 to the power minus 7. Fine. Only this formula. And what is essentially required? That is putting numbers and calculating is something that is very simple. So this way, students, we tried our level best to learn something new, to revise some basic concepts by means of some good collections of questions. My suggestion now again, keep revising. Let's stop over here. Very soon we will back with the new collection of questions. Till then, keep revising. Take care of. Bye-bye.